Hello friends, welcome back to my YouTube channel. So in today's video we'll see a problem of how to analyze a problem by using the flexibility method when the structure is having the both end fixed. So how to analyze it by using the flexibility method. So we'll see. So this is the given problem. A fixed end beam of varying cross section is shown in the figure. Find the fixed end moments by using the flexibility method. So in previous video we have already solved the two problems on this, but this problem is different from that problem because this problem is having the both the end fixed. So now we'll solve how to analyze it. So we'll see. So usually the first step is to find out the degree of static indeterminacy. So for that, in static, while explaining the static indeterminacy, I have explained in detail how to find the ds. So I will give link in the description box how to analyze the ds. So now we'll see. For that we have the formula R into E into EC. So R is the number of reactions. So at fixed end, how many reactions are there? Usually 3. One is vertical, one is horizontal, one is moment. So but when it comes to the flexibility method, we should neglect this horizontal one. We should neglect the horizontal one. We should not take the horizontal force because we should neglect the axial deformation. So when we are analyze the problem by using the flexibility method, so we should neglect the axial deformation. So it means total number of reactions at fixed end is here 2. So here also 2. So similarly our static equilibrium equation is 2. Summation of Fy is equal to 0, summation of all the moment is equal to 0, and summation of Fx. So we need to neglect this. Now I am not taking it. So only we need to take these two. So here how many number of reactions? Total number of reactions are 4, and how many equilibrium equations? 2. There is no any internal lines, or EC becomes 0. So 4 minus 2, it will be 2. So ds is 2. So here ds is 2 means what it means is we have to remove the 2 redundant from this. We have to release the 2 redundant from the structure. So I will show you how to release that. So here our structure is statically indeterminate structure. To make it statically determinate structure, we have to remove the 2 redundant from this. So I will release here, and at point A, at point C, I will show you how to release that. And see here our both the ends are fixed end now. So this is the statically indeterminate structure. To make it statically determinate, we need to release this fixed end to convert this fixed end into the simply supported beam, the structure into the simply supported beam. So I have converted this into simply supported beam. So now it is statically determined structure. So if a fixed beam has the more unknown reactions, then the available equilibrium equations, we can't find out basically by using the static equilibrium equations. So that I am making the structure into the simply supported structure. So here we have to release the 2 redundants. Here I am taking at point A coordinate number 1. I am releasing here, and I am also releasing here also. Call it as coordinate number 2. I am giving the name here coordinate number 1 and coordinate number 2. So I have also drawn the diagram also. This is our main diagram M. This is our M1 bending moment of coordinate number 1. This is bending moment of coordinate number 2. Here our coordinate number 1 is acting. Here our coordinate number is 2. We need to find the reactions for each diagram separately. So now we'll see how to find the reactions. So this is our main diagram. So for this we need to find the reaction. Here reaction, so here reaction RA takes place, here reaction RC takes place. So to find out the reaction, see here this is a 40 kilonewton unit load is acting. So this is a symmetrical structure. So for that we need to find the total load. So here total load is here 40 kilonewton unit load is acting, 40 into a distance of 6 meter. From here to here is 6 meter, 40 into 6. So calculate it, it becomes 240 kilonewton. So 240 kilonewton. So this is the simply supported beam with symmetrical uniform load is symmetrical unity. It is carrying the uniformly varying load, and the total load is shared by equally between the two supports. It means, so our RA is equal to RC, because it is a symmetrical, we need to divide by 2. So it will come out as 120 kilonewton. So your RA is also 120, RC is also 120. For the structure, this is the calculation. Now we'll see the when we applied the unit load at coordinate number 1, that is nothing but 1 kilonewton. So what happens? So before applying this 1 kilonewton, we'll find out the reaction. So RA is acting, here RC is acting. So to find out the what reaction, we have to apply the summation of all the moment about C. This is point A, this is point C, this is A, this is C. Moment about C is equal to 0. Here we need to take the clockwise positive. Here RA is moving clockwise, no, it is positive. So RA into at a distance of 6 meter, from here to here is 6, and into 6 minus here one load is acting, that is 1 kilonewton. So minus 1 unit load of 1 kilonewton is acting now anti-clockwise. So we need to take the minus 1 is equal to 0. So our RA will come out as 1 divided by 6. So 1 divided by 6, it is moving upward. So whatever the we have given the direction which is given the direction which we gave was right. Similarly for RC, we need to apply the summation of all the vertical forces is equal to 0. Upward we need to take the positive. Here RA we need to add all the vertical forces. Here we have only RA and RC. So RA plus RC is equal to 0. RA is 1 by 6 plus RC is 0. So RC will come out as minus 1 by 6. So minus means it is moving downward. It means the whatever the direction we gave was wrong. So make it as downward. RC is minus 1 by 6. Minus 1 by 6. Similarly, we need to calculate for our M2. We need to calculate the reactions RA and RC. Distance is 6. We need to apply summation of all the moment about point A is 0. Clockwise we need to take positive. Here it is moving anti-clockwise, no, RC is. So minus RC into at a distance of 6 from here to here, plus 1 unit load is acting, 1 kilonewton. So it is positive, no, the moment is positive, we need to take the positive 1 is equal to 0. So RC will come out as, if it comes here it becomes minus divided by 6. So minus will get cancelled, it becomes 1 by 6. It is upward. So it means the whatever the direction we gave is correct. It is moving upward. Similarly, we need to find the summation of all the vertical forces is equal to 0. Upward we need to take the positive. So here RA plus RC are the reactions is equal to 0. RA is equal to RC is 1 by 6. Now if it comes right side, it becomes minus 1 by 6. It is downward. It means so our RA value, whatever we gave, the upward direction is wrong. So we need to make it correct, that is downward. Minus 1 by 6. This is how we need to find the reactions. Now we'll move to find the unit load table. So we need to draw that. This is the unit load table. Here member is, we have AB and BC. So two members. Here we have AB and BC, two members. Here AB and BC. So for AB I am taking the origin as A. For BC I am taking the origin as C. Here EIC for AB, EI is value is given, that is I. And for this BC the value is 2 EI. Here 1 EI, here 2 EI. Similarly our limit is here 3 meter, here also 3 meter for AB, 0 to 3, and here also 0 to 3. So to find out the M1, this is our M1 diagram. So how to find the M1? For M1 we'll see, for AB I am taking the origin as A. So if I cut the section far away from this, if I cut the section x-axis far away from the origin A at a distance of x, here one RA is acting here, it is going upward. It means at what distance from here to here it is acting? It is acting at a distance of 120 into x. From here to here is x, so it is going upside. It means it is positive. So 120 into x. So here one UDL is also acting. So it is of 40 kilonewton. The UDL of 40 kilonewton per meter. So it is also acting. So at the distance of x it is acting. So from here to here distance is x. So 40 into x, it always act at a distance of half of the distance is nothing but x divided by 2. So 40 into x divided by 2, it becomes 40x square divided by 2. So and it is moving downward. So down means minus. So minus 40x square divided by 2. So we need to have it right here. So for that I am taking 120 into x minus 40 into x square divided by 2. So 2 into 2, so it will come 120x minus 20x square. So same thing I have written here. Similarly for M1, if you cut the section far away from the origin A, if you cut the section XX far away from the origin A, so here RA is acting, no, intensity of RA is 1 divided by 6 at a distance of from here to here is x. So RA into x is nothing but x divided by 6. So it is positive. Here one more moment is acting. So unit load is acting. So it is anti-clockwise acting. So it means minus 1 plus x by 6. So M1 will be minus 1 plus x by 6 is M1. So our M1 will be x minus 1 plus x divided by 6. So minus 1 plus x divided by 6. Similarly for M2, if we cut the section away from the origin, cut the section x6 at a distance of x. So here one load is acting. So RA it is going downward. So it means it has the intensity of minus 1 divided by 6. So minus 1 divided by 6 into x. So minus 1 by 6 into x is nothing but minus x divided by 6. So our M2 will be minus x divided by 6. Similarly for member BC, we have taken the origin as C. So origin is C. If you cut the section, x-axis away from the origin C, here if we cut at a distance of x, our m1 will become, so Ra into at a distance of x, so RC into at a distance of x, so RC, the intensity of RC is 120, so 120 into x, it is going upside, no, we need to take the 120 into x again and see the UDL is acting. So for that we need to take the 40 into at what distance it is acting, 40 into x into L divided by 2. L divided by 2 is nothing but x divided by 2. So again the same thing, 20 into x minus UDL. So 40 into x, it always act half of the distance, that is nothing but x divided by 2. So it becomes 120 minus 20 x square for m for BC. It becomes 130 x minus 20 x square. So now we see for the m1, if you cut the section x axis away from the origin C at a distance of x, here our RC is acting, it is downward, no, so at what distance it is acting, so x into minus 1 divided by 6, so it is nothing but minus x divided by 6, so m1 will be minus x divided by 6. Similarly for m2, if you cut the section x axis here away from the origin C at a distance of x, our m1 will be, see here RC is acting at what intensity, it has the intensity 1 divided by 6, so 1 divided by 6 into x, from here to here is x divided by 6, x divided by 6. So here also on unit load is acting, that is 1 kilonewton, so it is also minus 1, it is like the minus 1 plus x divided by 6, it is moving downward, no, so that we need to take the minus 1, so minus 1 plus x divided by 6. So this is how we need to fill the table by using the corresponding diagrams. So we need to find the f11. So for that we have the formula, integration of 0 to L m1 square ei divided ei into dx. So integration of, so limit is 0 to 3 m1 for AB is minus 1 plus x divided by 6, so minus 1 plus x by 6 whole square into dx plus integration of 0 to 3 for PCM1 is minus x by 6, here ei value is 2, here ei value is 1 divided by 1 into dx. So now solve it. So integration of 0 to 3 into minus 1 plus x divided by 6 into whole square plus integration of 0 to 3 into minus x divided by 6, x divided by 6 whole square is there, whole square divided by 2 is there, no, divided by 2. Solve it. Our f11 value will come out as 1.87 divided by ei. So ei value we already put, so ei value is given, no, here don't need to put ei because the ei value is given, so here ei means it becomes 1 and here 2. Similarly for f12 the formula is 0 to L, so for f12 and f21 formula will be same, f21. So here also the moment of first point, here also moment of first point, m1 into m2 divided by ei into dx. So 0 to 3, so m1 value for AB is this into this and this into this, minus 1 plus x by 6 into minus x by 6 dx, here value is 1, plus integration of 0 to 3 into this minus x by 6 into minus 1 plus x by 6 divided by ei value is 2 into dx. Now solve it. 0 to 3 into minus 1 plus x by 2 minus 1 plus x divided by 6 into minus x by 6 minus x divided by 6 bracket close plus this one plus integration of 0 to 3 into this one. So minus x divided by 6 into minus 1 plus x divided by 6 bracket close, divided by 2 is there, so divided by 2. So solve it. Our f21 and 12 value will be 0.75. Similarly for f22 we need to calculate f22 is equal to integration of 0 to L m2 square divided by ei into dx, integration of 0 to 3 m2 is so minus x divided by 6 for ab minus x by 6 whole square into dx, this is 6 plus integration of 0 to 3 into this one minus 1 plus x by 6 whole square divided by e2 value is 2 is there, we need to put the 2 into dx. So now solve it. Integration of 0 to 3 into minus x divided by 6 into bracket close whole square plus this one plus integration of 0 to 3 into this one, so minus 1 plus x divided by 6 whole square divided by 2 is there, divided by 2. So now solve it. Our f22 value will come out as 1.12. So f22 value will be 1.12. So now put all the value here. f11 value is 1.87, f12 is 0.75, here also 0.75, and f22 value is 1.12. So this is our matrix. Now what we have to do is we need to find the by using this formula we need to find the unknown reactions. P is equal to the inverse of matrix into dou matrix into dl matrix, so here it becomes 0 yielding because it's not given in our problem. We need to find the dl matrix. For that we need to find the d1 and d2. So how to calculate this I will show here. For d1 we have the formula integration of 0 to L capital M into small m1 divided by ei into dx. So now put all the value 0 to 3, m for AB is 120x, 0 to 3, so m1 is 120x minus 20x square into minus x divided by 6, so we need to write here 120x 120x minus 20x square into minus x divided by 6 into dx plus integration of for bc we need to this into this we need to do. So integration of 0 to 3 into 120x minus 20x square into minus, here we need to multiply m into m1. So this into this, no, see here what we are at, the value is minus 1 plus x by 6. So minus 1 plus x by 6, make it here. Here also this into this, minus x by 6 into dx divided by ei value is 2 is there, we need to put 2 here. This is minus 1. So now while entering the data, carefully we need to enter it, otherwise we'll get the error in our by calculating. So now by using calci we'll solve it. Integration of 0 to 3. So 0 to 3 into, so into this 120 x minus 20 x square, close the bracket, and again bracket is there, minus 1 plus x divided by 6 is there, close the bracket carefully, and plus this one. So plus integration of 0 to 3 into 120x minus 20 x square, close the bracket, and again bracket is there, minus x by 6. So minus x divided by 6, close the bracket, divided by 2 is there. So divided by whole divided by 2. And now solve it. Our d1 value will come out as minus 303.75 is the d1 value. d1 is equal to minus 303.75 for d1. Similarly we need to find for d2. Integration of 0 to L capital M into M2, moment of second coordinate we need to take here, divided by EI into dx. So integration of 0 to 3, limit is 0 to 3 is now, we need to now m into m2. So capital M into m2, this one, and this into this one we need to do. So 120x minus 20x square into minus x divided by 6. For AB, 120x minus 20x square into minus x by 6 dx plus 0 to 3. For BC, 120x minus 20x square into minus 1 plus x by 6. So 120x minus 20x square minus 1 plus x by 6 divided by 2 into dx is there. So here value is 2, no? So for that we need to put the 2 here. So now by using calcium to solve it, here only I am adding. So 120x minus 20 square, here minus x divided by 6 is there. So make it minus x divided by 6 plus this one matrix we need to add. So 120x minus 20x is there, and into minus 1 plus x divided by 6 is there. So into minus 1 plus x divided by 6 divided by 2 is there. Now solve it. It will come out as d2 will come out as minus 236.25. So d2 value will be minus 236.25. So now we need to add d1 and d2 value in this equation. So here our P matrix is nothing but, in our question, the what they asked to find out the fixed end moments. Find the moment
In case of P matrix,
I am taking the moment MA and MC. So our P matrix will be, how many redundancies there? We got 2 redundancies there no in our problem, so that we need to take the here also 2 members. For that I have taken MA and MC. So again flexibility matrix, this one we need to add 1.87, 1.87, 0.75, 0.75 and 1.12. We need to do the universe of this. Into here this value is 0, no, I am only adding this one. So minus of this matrix, DL matrix is D1 and D2. D1 we got was 303.75 and D2 we got was minus 236.25. So now we need to calculate MA and MC by using calc. I will show how to calculate here. See here. So to find out this, press mode here at number 6 matrix is there, no, press the number 6 here and you could see like this, and here mat A is at number 1, no, we need to press the 1 here, and again see here our matrix A is 2 into 2 matrix, no, so 2 into 2 matrix is here at number 5, so press the 5 and enter all the value 1.87, 0.75 is equal to 0.75 is equal to 1.12 equal to, now we need to press the here AC here, then press shift, then 4. You could see here data at number 2, then press the number 2 here, then we need to enter the matrix 2, it is at number 2, no, we need to press the here 2. So now see here our matrix 2 is 2 into 1, no, so 2 into 1 means we need to press the 6 again here, so press 6. So now enter this value minus 303.75, minus 303.75 and minus 236.25, minus 236.25. so now press AC, then again press shift here and press one more time 4 here, and then here our matrix A is at number 3, no, so press 3 here and see your mat A will it came. Now we need to do the universe of this, no, for that see here you could see the symbol of universe here, now press it, see our matrix A universe, so into
matrix B is there, no, minus into matrix B,
minus we need to enter the matrix B, no, so again shift, press shift here and again press 4. So see here our mat B is at number 4, press the 4 here, see our mat B will came. So now solve it, press the is equal to button, so here you could show the value, so 106.41 is nothing but our MA value, so 106.41 is MA value, right? MA value we got was 106.41. Similarly our this value is 139.67 is nothing but our MC value 139.667. so see, this is how we need to find the final moments. So our MA will come here, so moment, so MA the value is 106.41 and MC is here moment 139.67. so this is how we need to find moment at A and moment at C. So here our problem ends. So if you like the video, like it, share it and subscribe for the more videos. Thank you for watching.